All right, in this last video, I'm just going to do a couple more examples of factoring. So after you watched the last video where you got to see a couple examples, hopefully that was a little bit of a refresher from Algebra 1. So here we're going to do two more examples of factoring, and then I'm going to have you do a couple on your own. So here, remember, when we're doing factoring, we are taking a trinomial and splitting it into two binomials. So what we need to do first, before we can even get ready to factor, we have to make sure that we've put our equation, our function, in standard form. So here we've got x squared minus 4x equals 45. So what we need to do first is we need to subtract 45 from both sides. So now we've got it equal to 0. So x squared minus 4x minus 45 equals to 0. Now, what we're looking at is, if you remember from the example video, this is kind of like a game where we're trying to find the factors of 45 that add together to our middle term. So what we're going to do here is, we know, again, since there is no coefficient in front of our first term, we know that this is going to look like two binomials multiplied together. And since the coefficient is 1, there's no number, we know that both of our binomials are going to start with x. Okay? Again, because there's no other coefficient here, so it's just x times x gives us x squared. Now, in this case, we see that our last term, our c term, is a negative number, is minus 45. The only way we get to a negative number is by multiplying together a positive and a negative. So we know that we're going to be adding a number in one of our binomials and subtracting a number in our second binomial. Because remember, when we FOIL together these binomials, our c term is the product of these last two digits right here. So we know that one has to be positive and one has to be negative. The order doesn't matter. We could have written the minus first and the plus second. That doesn't matter. So what we're looking for here is we're looking for the factor pair that multiplies together to give us negative 45 and adds up to negative 4. Now, one method that you may have learned is, we call this the diamond method. And what it does is it helps you organize your terms a little bit. So what you do is you write this x right here, and on the top you're going to write your a times c. So you have your a, b, and c values from your standard form. So ax squared plus bx plus c. You're going to take your a value multiplied by your c value. So here, if we were going to do this, it would be 1 times negative 45. So we're going to write negative 45 on top. And you write your b value on bottom. That's your middle term. So negative 4. Okay? So what we're doing here is we're now going to try to find the two numbers to write on the sides of our x. We're going to find the two numbers that multiply together to give us negative 45 and add up together to equal negative 4. It's like a puzzle right here, like a number puzzle. Okay? So what you want to do is you want to start looking at the factors of 45. So we've got 1 and 45. Okay, we know that just those don't add up in any form to give us 4. 2 doesn't go in. We've got 3 and 15. Again, 3 and 15, there's no way through adding or subtracting that we're going to get 4. And we've got 5 and 9. Now look, you'll see that 5 and 9 they have a difference of 4. So that's going to be our factor pair that we're going to use. Now, in order to get negative 4, we have to figure out which one of these two terms is our negative and which ones are positive. Well, if we did positive 9 and negative 5, that would give us positive 4. So we know that this is going to be positive 5 and negative 9. Those are going to be the two numbers that multiply together to give us negative 45 and add up to give negative 4. So when we factor, those become our answers. We put them in here. So now that we're trying to find our solutions, remember, we're not done yet. This isn't just factor. We have to solve by factoring. Now we take each one of our binomials and set it equal to 0. So we're going to get, in this case, if we subtract 5, we get x equals negative 5. And if we take our second binomial and set it equal to 0, we do x minus 9 equals 0. And now to isolate, we would add 9 to both sides, and we would get x equals 9. Okay? So there are our two solutions to this problem. Now, this is one of the simple ones. Whenever you have x squared by itself with no coefficient, these ones are generally simple. You can do this diamond number puzzle, and whatever answers you get go directly into your binomials. Okay, so this is the first type of problem. Let me go ahead and show you an example of the second type of problem. So here we've got a trinomial that has a coefficient in front of x squared. So we're gonna do the same steps, but we have to do a little bit more, trying to be a little bit more aware of the factors that give us our a, b, and c terms. So let's go ahead and go through this. So first thing we want to do, find the zeros. Okay, that's finding the solutions. So first thing we want to do is set this equal to 0. Okay, so we're going to set f of x equal to 0. Now, what we want to do is when we look at our expression right here, we see that our first term has a coefficient of 2. So what that tells us is that when we split this up into our binomials, we know that the first two terms multiplied together have to give us 2x squared. Okay? Remember, when we're foiling, we multiply our first two terms together. That's going to give us our a term, our 2x squared. The only two numbers multiplied together that give us 2 are 1 and 2. So we know that one of our binomials is going to start with a 2x, and the other one is going to start with an x. Okay? If this were 3, then we know that these numbers would be 3x and x. Now, if this was 4, we would have some more options. We wouldn't know. It would either be 2 and 2 or 4 and 1. So we'd have to do some kind of guess and check and process of elimination. Factoring, a lot of it is done mentally, and you have to kind of try some different factor pairs to see what's going to work for you. But here, when you've got a coefficient like 2, you know that 2x and x are the only two numbers that are going to give you 2x squared. Now, let's look at other components of this. We see that we've got minus 11x plus 12. Now remember, like that previous video, when your last term is positive, you know that both of your signs in your binomials have to be the same. They're either both negative or both positive. If they were both positive, then we would also have a positive number in the middle. But since this is negative, we know that we're subtracting. Okay, we know that these both have to be negative because that'll give us the positive 12, but also the minus 11x. Okay, now at this point, we need to figure out what factor pairs of 12 go inside here to make this trinomial. So let's write out the factors of 12. We've got 1 and 12, 2 and 6, and 3 and 4. Okay, those are the only factor pairs. We know that one of those pairs has to go in here. Now, if we did 1 and 12, if we plugged in 1 and 12, we know that wouldn't work because we'd have 2x times minus 12, which would be minus 24, and then minus 1 would be minus 25. That's too many. Even if we reverse those and put 12 here and 1 here, we'd have minus 2 minus 12. That'd be minus 14. We know these can't work just by process of elimination. 2 and 6. So if we plugged 2 in our first and 6 in our second, we'd get minus 12 minus 2. That's minus 14. If we switch those around, we'd get, if we did the minus 6 in the front, we'd get minus 6 and then minus 4. That'd be minus 10. That's close, but still not quite. So it looks like 3 and 4 has to be our solution, but let's make sure we put them in the right order. So if we do 2x minus 3 and x minus 4, that means we're multiplying negative 4 by 2 to get negative 8, and then negative 3 by x to be negative 3x. That looks like it's going to work. So we can go ahead and plug in our 2x minus 3 and x minus 4. So that's gonna give us our factor pair. Now, to find the solutions, let me go ahead and I'm going to take this off, but it'll come right back on. Let's go ahead, now that we found our factor, let's go ahead and find the x values for which f of x equals 0. So again, what we have to do is set each of these binomials equal to 0. So 2x minus 3 equals 0, or x minus 4 equals 0. And now we just have to isolate x. So on our first one, we can add 3 to both sides and then divide by 2. So we get x equals 3 halves. And our second, add 4 to both sides. So we get x equals 4. So we get x equals 1.5, or 3 over 2, and x equals 4. And that's our solution. Those are the zeros. They're also the same things as the x-intercepts. So you can check this by graphing. With any of these functions, you could plug them into a graph and make sure that you get the expected answers. Because remember, the zeros and x-intercepts are the same thing. What I want you guys to do, I want you to go ahead and I want you to give 7, 8, 9, 10 a try. So solve the equation by factoring and then finding the zeros. Basically, same steps that you're going to be doing in them, okay? So use factoring if you can to find each of these. And go ahead, enter your answers in 7, 8, 9, 10 into the box that comes up now.